I said in the last video that we were going to move on to the implementation of radix sort, but when I was looking over the implementation, I thought it would be helpful to go through the stable counting sort that we're going to use first before we actually get to the implementation. So that's what we're going to do in this video. So as I said in the video about counting sort, the implementation that I showed you was unstable. If you want it to be stable, we have to do some extra work. Now, the implementation that I'm going to show you calculates where values should be written back to the original array. And then by writing the values into the array in backwards order, we get stability. And I think probably going through the slides will make this clear. In the last video, we went through sorting this array, and I'm going to go through the stable counting sort for when we sort the array based on the tens position. And so if you look at the last video, we've already sorted based on the ones position, and we end up with the array on the screen. And now we're going to sort this array based on the tens position. And the reason we're looking at the tens is because the tens actually have some duplicate values. So 1594 has to remain after 8792 after the sort, and 5729 has to remain after 4725 because the sort has to be stable. So how are we going to accomplish this using counting sort? So what we do is we do the count just as we did before, and we're going to end up with the counting array below. So we have two values that have 2 in the tens position, 4725 and 5729. 1330 has a 3 in the tens position, and then we don't have any 4s, 5s, 6s, or 7s in the tens position. 4586 has 8 in the tens position, and then we have two values with 9 in the tens position, 8792 and 1594. And so our counting array is what you see in the bottom, 0021, 000012. And so that tells us we have two values with 2 in the tens position, one value with 3 in the tens position, one value with 8 in the tens position, and two values with 9 in the tens position. And that's all fine and dandy, but how are we going to write these values back? Because we don't actually have the values in the counting array. And on top of that, we want the sort to be stable. And so what we're going to do is we're going to create a temporary array that matches the length of the array we're sorting. And so we're going to create a temporary array of length 6 because we're sorting 6 values. And we can use the counts to figure out which range of indices in the temporary array will be occupied by each value. For example, because we don't have any zeros in the tens position and any ones, we know that the two values that have a 2 in the tens position are going to occupy positions 0 and 1 in the sorted array. And then we have one value with a 3 in the tens position, so we know that'll go into position 2. And then we don't have any values with 4, 5, 6, and 7, but we have one value with an 8, so we know that's going to go into position 3. And then positions 4 and 5 are going to hold the two values that have a 9 in the tens position. So because we know how many values we're sorting, and because we know how many of each value have a specific digit in their tens position, we can figure out what range of positions the values with a specific digit in the tens position are going to occupy. The way that we figure out these ranges is after we've done our first counting pass and we've ended up with our usual counting array, we adjust the counts. So instead of just keeping the number of values that have a specific tens digit, we want to store how many values have a specific tens digit or less. So for example, at index 3 in the counting array, which currently contains the number of values that have a 3 in the tens position, instead of that, we want to know how many values have 3 or less in the tens position. And in this case, that's 3 values, right? Because we have two values that have 2 in the tens position and one value that has 3 in the tens position. And so we have 3 values that have a 3 or less in the tens position. And we can calculate how many values have a specific digit or less by summing up all the counts that come before it. And so, for example, by summing up 0, 0, 2, and 1, we get 3, and that's how many values have a 3 or less in the tens position, right? Because we don't have any values with 0. We don't have any values with 1. We have 2 values with 2 and one value with 3. And so after we've adjusted our counts, this is what we get. So we don't have any values with 0. We don't have any values with 1 or less. We have 2 values with 2 or less. We have 3 values with 3 or less, and then 3 values with 4 or less, 3 values with 5 or less, up to the value for 8, where we have 4 values that have 8 or less, and then finally we have 6 values with 9 or less, and that last position is always going to basically equal the number of values we have, because everything in the array is going to have the highest possible digit or letter or less. And so this is our adjusted count array, where each element, instead of containing the exact count of how many values have a specific digit in their tens position, instead it contains the count of how many values have that digit or less. And now we're going to use that to write back to our input array. So the code at the top is what we're going to use. So we initialize our temp array, and n is the number of elements we're sorting. So we'll have a temp array of length 6, and then we traverse the array backwards. So we traverse the array from right to left, because this is going to make us write the rightmost values before the leftmost values, and that's what's going to ensure stability. And so we start with n of 6. K is going to go from 5 to 0. So when k is 5, we're going to get the digit in the tens position. That's what that get digit method is doing. And we're going to get it for input k, and k is starting at 5. So if we go back, that's 5729. We're going to look at count array 2, because we're going to figure out that the get digit call is going to return 2. And so we're going to index count array 2, and we're using the prefix operator. So we're going to subtract 1 from count array 2. That's going to give us 1. And then we're going to assign input k, which we just saw back here is 5729. We're going to assign that into temp 1. So let's go through that one more time. We're going to get the digit of input 5, and that the tens digit, and that digit is 2, because we're dealing with 5729. And then we're going to decrement the value at count array 2, which is going to give us 1. And then we're going to use that result as the index into our temp array. So we're going to assign input of k, input 5, which is 5729, into temp at position 1. And so we're going to end up with this situation where we have 5729 in the temp array. So now we have the temp array at the top and our count array at the bottom. Now we've decremented count array 2 by 1, because we've written 1 value with 2 in the tens position. And notice that it's gone into temp array 1. And so the second value that has 2 is going to go into temp array 0. And because we're going right to left in the input array, we're writing rightmost values before leftmost values. So that means if we have a duplicate, the rightmost duplicate will be written to the right of the leftmost duplicate, and that's what's preserving the stability. And so now k is going to get decremented to 4. We're going to be handling value 4586. The tens digit is 8. So we're going to decrement count array 8 by 1, which will give us 3. And so we're going to assign 4586 into temp at position 3. And we're going to end up with this situation. So 4586 has gone into the temporary array at position 3, and count array 8 is now 3, because we've decremented it by 1, because we've written out 1 value with 8 in the tens position. So now k will be 3, so we're going to be handling 4725. That has a 2 in the tens position. We're going to decrement count array 2, so that's going to become 0. And so we're going to assign 4725 to temp 0. And so this is our array, and notice that we have preserved the relative positions of 4725 and 5729, because we're going right to left. So when we write the rightmost duplicate value, we write that value into the rightmost position of the set of positions for that tens value. And so we knew that the 2 values that have a 2 in the tens position, we're going to occupy positions 0 and 1. And so we write the rightmost value in the original array into position 1, and the leftmost value into position 0. And by doing that, we have preserved the relative position. So this is a stable sort. And you'll notice now that count array 2 is 0 because we've now written out both values with 2 in the tens position. So now when k equals 2, we're going to be handling value 1594. It has a 9 in the tens position, so we're going to decrement count array 9. It'll become 5, and then we assign 1594 to temp 5. And so the rightmost value with 9 is being written in the rightmost position for values that have 9 in the tens position. K will be 1, we'll handle 8792. We decrement count array 9 to 4, and we assign 8792 to temp 4. And we have preserved the relative positions of 8792 and 1594. And then finally, k will be 0. We'll handle 1330. We'll subtract 1 from count array 3 to get 2, and we'll write 1330 to position 2 in the temporary array. And there we go. We have completed our sort of the values based on the tens position, and the relative positioning of any duplicates have been preserved. And so this is a stable counting sort. It works because we traverse the input array from right to left, and we write duplicate values into the temp array from right to left. So if we know that duplicate values will go into, let's say, positions 3 and 4, we write the rightmost value in the input array into position 4 and the leftmost value into position 3. And this preserves the relative positioning of duplicate values. And so by adjusting the counting array after the initial pass, so that we, instead of storing just the raw counts, instead we store how many values have that value or less. So for us, it was how many values have a specific digit or less in the tens position. We can use those adjusted counts to map values back to indices in the temp array. Now, another way of doing this is to use something called linked lists. We haven't covered those yet. We'll be covering those soon. But another way of doing this is, instead of just using counts, the way that we did, you can actually store a list of the actual values at each position in the count array, and then you write the list out backwards. So we're not going to cover that because we haven't covered linked lists yet, but that's another way that you could do it. Now, obviously, we've sorted into a temporary array. So at this step here, the top array is a temporary array. So obviously there would be one more step, and that would be copying the temporary array back into the input array. Okay, so that's it for the stable counting sort. The code up here is the code that we're actually going to use in the implementation. So now that you've seen it, when we code the implementation, I won't have to spend time trying to explain to you what's going on and not having any slides to do it. So I thought that having slides and going through it would make it easier for you to understand. So now, finally, let's move on to the implementation of radix sort. I'll see you in the next video.